Excuse me, is the final exam open note?
Oh, you mean the Canvas exam for final?
Yeah.
Yeah.
It is? Okay.
Yeah. Same as me.
Thank you.
All right. When is our project review? Sunday, right?
You're gonna extend it? You're gonna extend it?
One question regarding once I upload the actual program, my main change the name in the canvas.
It's okay. It will correct.
That's one.
Yes.
And then for me, when I finish the thing and running the main, that day was keep saying the main is not found. And right now he looked at it.
It's fine.
Yeah, I think his eyes just fixed
So
it.
as long as you
and
upload the main, then it should be fine. Yeah. Just upload the most latest
That's
one
why I
that
said, is
runs.
something common happened?
No. Unless you have different files in your folder or something. I mean, it runs is good.
Yeah.
If it runs, you're good. Yeah. What? It has Monday?
Yeah, it's the 24th.
Trying to trick me. Hold on. 20.
Also Monday. Whoa.
Oh
No, no problem.
no. You all just accidentally got a actual day. You're right. 24? Okay, I guess you get an actual day. I'm not going to change it back since it's already out. You are correct. You have one more day. Monday. My mistake, your reward. Alright, I will extend the deadline for the late then. Because right now the only people will only have 2 days for late. So I'll extend the late to Thursday. So Thursday midnight. Is that what I call it? Thursday night midnight. So the Friday morning was the latest you could submit it. I will change that. Alright. Oh yes.
Extra credit, so it doesn't hurt our grades.
I can't. So okay, I can't bother right now. But the thing about Canvas is that I tried so many ways to not, because Canvas allowed me to do extra credit for a session. So I can do extra credit for say projects only, or I can do extra credit for exams only, or I could do extra credit for homeworks only. I cannot do extra credit for the whole class. It doesn't allow me. So for me to do it, I set the total grade to be 108. So when you think that it hurts you, it doesn't, because if you don't do any of the extra credit, you will still have the total is still 100. So right now the total grade is 108. But I won't, yeah. So don't worry about the percentage because that's what they use to calculate something over 108. That's not accurate, but the raw grade will be accurate. All right, are we ready for polymorphism? For me, polymorphism is probably the most difficult of C++ for this entire semester. The next one is exception. It's where you use classes to write a special thing for you to throw exceptions. Polymorphism really depends on inheritance. Even the name is long, right? Exception is exception. You know what it is. But polymorphism is the core of C++ and why it's powerful. You see interview question asks you to just tell them what's polymorphism because it is the core of this language. All right, let's review inheritance to make sure we're on the same page before we go into polymorphism. Inheritance, we introduced the name base class. We introduced another term derived class, right? The relationship between is that the base class can be inherited into derived class. When you have base class and derived class, the relationship between the two is an is-a relationship, right? Grad student is a student, so student base class, grad student derived class. An admin account is an account, so account base class, admin derived class. Property of base and derived are as the following, right? When your derived classes derive from the base, you first of all inherit everything over. You have a copy of everything that you have from the base class, except for construction, destruction, and assignment operator. Once you inherit everything over, you can still make your own constructor. Your constructor will trigger your base class constructor either implicitly or explicitly, right? You could either trigger it if it's not default, or it will be called no matter what when you have a default. For public and protected member of your base class, your derived class can directly read and write, right? For private, right, which you do inherit over, you do have a copy, but you can't directly modify it. You have to go through base class functions or constructors to modify the private because they are essentially still private to the base class. You can add new members to the class, and you can also override member functions of your base class. When you override, it means to redefine what base class, the function that base class already has with a different definition. For that, most of the time you will be triggering the base class function to start with, and then extend or add on top. Let's review our example from before. This is calling constructor explicitly with the function override. Our base class example student, where it has its constructor over here, which is defined over here, right? All that's doing is assigning parameter into their private members. For your derived class, you can call constructors from your base class. When I say call, it's basically passing in parameter over. The order doesn't matter, name doesn't matter, as long as they match what you want. So like the base class constructor takes a name, test 1, test 2, test 3, then it has to be first name, test 1, test 2, test 3. Alright? The second thing is function override. So if you look at the base class has a function called grade already. When you have your derived class for a student, we are overriding the function definition of grade. And to begin with, we start with calling the base class function. And then you can add on top of it. Alright? When you have private members from the base class, most of the time you trigger them, you access them through constructor, gather, and write and set from the base class. That's the only ways you can trigger, you can modify them, right? Because you don't have access to them. All right, how about default constructor? For default constructor, which is a constructor with no parameter, right? Your derived class constructor will trigger them no matter you want it or not. And it will trigger them right before your own constructor being triggered. All right, so you don't have control over it. If there's a default, it will be run. Destructor also got triggered in the reverse order. Like when we first talked about destructor, we talked about destructor, they are triggered in the reverse order, similar to when you have this relationship of base and derived. When the constructor being triggered, base constructor will be triggered first, right? And then your derived class constructor. Therefore, the destructor will go the other way around. Your own destructor will be triggered first, and then finally your base class destructor. Okay, so remember, it's always flipped. It's possible to have multiple base classes. You can have a derived class over here that derived from first student, then account. The order does matter because when you are triggering their constructor, they are triggered in the order in the order that you have them derived from. So for this example, we'll zoom out. because I inherit student first, so it will be student constructor, and then the second one is account, so account constructor, and finally my own constructor. Right? Another thing I didn't cover is if you have something like that, right? First, second, and the third, when the destructor is being triggered, it will go completely reverse. So first, second, and the third. Okay? All right. Now we're ready for polymorphism. We talked about inheritance. We talked about base class, derived classes, right? You can also have model base class, same derived classes. The reason that we establish relationships between classes is so that we can set something I've been calling it the family tree, where you have a same base class which will just expand out to derive and then continue to derive, right? And then the whole family can be used in polymorphism. Now polymorphism is where it allows you to write a program that understands and process a family of classes. Not just one, not just two, but anything with the same base class. Alright? Because we are handling multiple classes all at once, polymorphism can then only work with pointer and references. And the way that, the kind of philosophy behind polymorphism is exactly because of the is-a relationship between the base class and the derived class. So say that I want to have a function that handles all accounts, right? As long as admin account, student account, teacher account, faculty account, all inherit from the same base class account, they're all accounts. So now when I write a function or a program that handles accounts, I can include all of them instead of writing one for each, right? So here are some examples for that. All right, so that's the concept. Before we go into example of polymorphism, let's talk about pointers. Remember, we have been touching on pointers throughout this class, and now let's look at class pointers. We have our same base class, student, derived class, grad student, right? Same as the one we had before. Now remember at the very end of last week, we moved the private members into protected because that is more friendly with our derived class. So this is our final version of our example from last week, where you have base class student, protected members, right? Has own constructor. And then the derived class grad student can directly access the protected members however they want, and then I added a print statement. With that, let's look at pointers. Here's my example. I have main. In there I have my object grad student, which is S. All right. 3 ways of calling the function. The first one is simple as .print, right? Print is a function. You trigger a function from a class. You have been doing that all the time. So pretty standard, pretty okay. We also looked at the pointer call, but the way that we looked at it was from the this pointer. That is actually universally applicable to any pointer. If I have a grad student pointer that points to a grad student object, right? Remember this pointing? You have pointer points to address of object, right? So pointer points to object. When I trigger my function through the pointer, you need to use this arrow, right? So it's pointer, arrow, and then print. Okay? So if you look at that, here's what's happening in the memory. My type is grad student, and I have a name S, that is my values, and that's my address. So say that I have my pointer, what's my pointer? Here's my print pointer, type grad student pointer, name pointer. Values is what? The address, and it has its own address as well. Right? Remember our pointer? Same thing for class, right? Exactly the same thing for class. Pointer is just a variable that only holds address. That's all that is, right? So when we have a pointer to a class, all that is it holds an address of an object. That's the only difference. Alright, now let's look at reference. The last one is we are going to create a grad student reference called ref that refer to as, in memory, all that's happening is that you have a name. Okay? This is all that is happening from this line, right? I give it another name for the same object that I have in my memory of this address called ref. And the way that you call the function through ref is exactly the same as how you just trigger it from S. So just ref dot print, S dot print, right? So those are all the same thing when you want to trigger a function from a class object through value, through pointer, through reference. Now let's look at this interesting thing on pointer. I have two objects, student objects as 0, grad student object as 1, right? And the relationship between S1 and S0 is that the grad student has a base class of student. That's all, right? I can do S1.print, all good. I can have a pointer, student pointer, that points to student, right, which is my S0. I have a grad student pointer that points to grad student, S1. Yeah, pretty straightforward. Now, my student pointer can also point to my grad student object, right? My base class pointer can point to my derived class object, not the other way around. You cannot have derived class pointer point back up to the base class object. This is not allowed. So your pointer only works its way down in the family tree. If you imagine base class is up here, and then you have grad student, undergrad student, all kinds of students down here, right? Pointer can point down, it cannot go back up. Here's an illustration. So if you think of, from now on, can you see orange? Yes, orange. All the oranges are base, all the blues are derived. So student pointer points to student object, no problem, right? Grad student pointer point to grad student object, also no problem. Student pointer can point to grad student object, yes. Grad student pointer cannot point to student object. We good on this one? Okay. All right, let's look at a little bit more complicated example where I have student object that has undergrad and grad student, so student pointer can point to all of them, right? Similar for our account, remember account we have admin and then VIP account. My account pointer can point to all of them as well. However, I did not make the slide. However, any of the blue pointers cannot point to any of those two. Okay? Alright. Now let's add on to our example the overriding function. So we have a function print, right? In my undergrad student class, print just saying that printing student. For my grad student class, it's saying printing grad student. They have the same name, that's overriding, right? When we inherit base class student, it already has the function print. When I'm overriding it over here, that is overriding the base class function. Now let's look at this example. We have student as, grad student as 1, right? As 0.print, that will print student. Okay, so student constructor being called, grad student constructor being called, and then we will have, right, and then student and grad student being called, and then we have as 0.print that will print student, as 1.print that will print grad student. Yeah, pretty straightforward, all good, right? As 0 is base, as 1, as 0 is student, as 1 is grad, so it do its corresponding print. All pretty good. Now let's look at pointer. We have student pointer that points to student object, right? So student pointer points to my student object, which is as 0. And when I call print, I have to do the arrow right now, right? Because it's a pointer. So I do that. That will give me student object. Pretty good? Now, so for grad student, same thing. When you have grad student pointer that points to grad student object, when I print, it will print grad student. We good? However, when we have student pointer, which is my base pointer, points to my grad student object, which is allowed, right? Remember, it can point down. It just cannot point upward, right? So point down. When I print, it will print student object. So what this is showing you is that your pointer type, right? So my pointer type, this is student, determined where you go look for the function. Even though my pointer is pointing to grad student object.
So to simplify it, I can take money from my kid, my kid cannot take from me.
No, I think your money will always say that this is not a print function, it's a cost function.
Yeah.
Parents always cost. It always costs parents. Even though you have your cost pointed to your children, no. It's always your money.
I have a question.
Yeah,
So here is going to print a student.
that's right.
Can you repeat that again? Why nothing happened?
So what happens is that when you're using pointer to trigger function, the function that's being triggered is determined by the pointer type. So my pointer type is student.
Okay.
So when I trigger the print, it will go to student. Even though my student pointer is pointing to grad student, it doesn't matter. No matter whether student is pointing to student object or student is pointing to grad student object, the minute that you call student pointer print, it will print from student. It will not print from grad student. Right? Alright, to summarize, we have class pointers that can point to base class and its derived class. Right? However, when you are calling a function from any pointer, it's being triggered by the pointer type, whatever the type is. If the type of that pointer is student, you call from student. No matter whether you're pointing to that, or undergrad student or other student, it doesn't matter, right? It just look at what your pointer type is, trigger from that class, not from any of our objects. Yes?
Can you change the member with that? If
Can
you
you change?
point the, like, because you cannot use the function from, like if the pointer is for like class student, it's gonna like print the, like it's gonna use that function from the student.
That's right.
But how about the member of this? For example, like this pointing the, let's say is equal to S1. Can we change the member from S1? Like from grad
That's what this is.
Yeah, that's one.
So right, so it is pointing to S1,
Yeah, so
which
we
is
can,
this.
okay,
You cannot.
we cannot.
So when I print, so it is pointing to S1 right now, right? But when I print, it still prints to the object.
I understand, because that calls a function, but how about the member? Can we change the member from grad student because it's pointing, because it's equal to S1 or not?
Oh, no, you cannot. Everything is from the student class. Everything is from the student class. But you normally don't do this for members though, right? You call function use pointer.
Yeah.
Yeah.
Okay.
All right. Now we talked about the nature of class pointers and what are some limitations of it. Then why do we have this thing? Right? That's exactly what I was talking about when you have a function that you want to take in multiple classes. For example, we have our base class memo that has a function talk. Right? Now I have 3 classes of different animals. We have dog, cat, and cow. They all inherit from public inherited from memo. They have their own function talk that talk differently. Right? Mammal, I don't know how mammal talk, I just say hi. Right? But then for each of the animal, they have their own sound that they make. Inside my main, what I want to do is that depends on what I pass into the talk function, whatever that talk function is. No, okay, I'm going to show you on the next slide. What I have a function called memo talk. Whatever I pass into that memo talk, I want that corresponding memo talk. This function, I only want to implement it once. I don't want to implement it multiple times. I don't want to have a cat memo talk. I have a cow memo talk, which you can do, right? For every single function when you define it, you can define what you're passing. You can be like memo talk cat, memo talk cow, memo talk what's another dog, right? You could do that. I don't want it. I want to have my code stay dry. I want to implement it once and once only. How do I do that? Your first instinct will probably go to the things that you're most familiar with, templates. Templates allow a function to take in different types, right? Perfect. If I have a templated function called memo talk, I just have this as t. That can be cat, that can be dog, that can be cow. The problem is that can also be bird, right? I don't want it. I only want dog, cat, and cow because it says memos. When you have templated function, you are allowing any types. You're not allowing a family of types. You're allowing any types that can go in. I can even have this as integer, right? It will not work because integer doesn't have a talk function, but t just has no limit. You can put in whatever. I want to still limit it into the memo family, nothing else. So for me to do that, that is where our base class pointer comes in. Our base class memo, right, have 3 children, dog, cat, and cow. If I have a memo pointer, it can point to all 3 of them and only the 3 of them. It will not be able to point to bird. Alright, so that should solve my problem. I'm going to have a memo talk function that takes in the parameter pointer of my base class memo, meaning that whatever that comes through here can only be in here. Right? So that's base class pointer. Base class pointer allow you to handle a family of classes. All right, let's try this memo pointer thing. We have our talk that takes in a memo pointer m, and I'm going to trigger the talk using the pointer symbol, right? So m talk. Here's my memo talk. It will say hi. Now here's our main. I have memo pointer. First, I have my object cat, and I have my pointer point to cat, right? I'm going to pass that in. Right, this is the memo pointer. I'm going to pass in the pointer, which now points to cat. And then I'm going to have my dog. I'm going to have the same pointer points to dog. Remember, pointer can be reassigned. Same pointer can point to different things, right? Reference does not have the same thing, but pointer does. This pointer points to cat. Now I change it to dog. I pass in the same pointer to my memo talk, which now points to dog. Then finally make sure you delete it. But then it makes me happy, right? Now I have a limited amount of classes that the pointer can point to, and it can be passed down into my memo talk. There's one problem. Your pointer trigger function based on the pointer. Your pointer does not trigger function based on your object. Meaning, no matter I'm pointing to cat or I'm pointing to dog, it's always just going to say one thing. Memo says hi. Right? That's all that's going to do. Right? So let's trace it down. We go in here and talk. Go up here. Memo says hi. Come back down. Do it again. Oh, do it again. Memo says hi. Right? Because you always have the pointer of memo being passed in. It will always trigger memo talk, not dog or cat or cow. Does this make sense? Perfect. That's a problem. How do we solve it? been seeing it's called static binding. So what happens when you create a pointer of a class, the minute you create that pointer, all of the class objects, everything inside class object is bounded. Meaning that when I have memo star memo pointer, functions, variables, everything got bounded together with this pointer at that point. Okay, this is called static bounding, and it's the default behavior of C++. But we can change it into what we have as dynamic binding, meaning that I want to have a function or multiple functions that do not get statically bounded. And the way you tell C++ to do that is put virtual at front. So you do virtual and you keep your function, right? Now with that, that's just the only one thing that you change, put virtual. It will now do dynamic bounding. The minute that we create the pointer, it will bound everything else except my virtual function. Right? Therefore, if you want dynamic bounding for 3 functions, you need to have virtual at 3 different places. So it will still static bound everything else, but it will skip virtual. So when I have virtual void talk, it will not be bounded here. Now when will it be bounded? It will be bounded when you are pointing to an object, and the object type will be what's being bounded. So now if you look down here, when my memo pointer points to cat, that's when my functions are bounded. When I have my memo pointer point to cow, that's when my functions are bounded. With virtual functions, we can have the desired behavior of this memo talk function. Yeah? Good virtual function? All right, to make it more complicated, we have pure virtual function. Now, why is that? Remember our example? We had memo, which is our class. We have our virtual function. Yeah, looks good. And then we have our 3 derived classes, dog, cat, and cow, right? We'll zoom in. We have dog, cat, and cow. As the base class, you don't have control over how they define it. I can have nothing inside my dog. I cannot override talking cat. I can decide to override whenever I want in cat. You don't have control over how your derived classes operate. But if you, okay, so I'm just going to show here, right? So what's going to happen when you don't have them overridden? Good thing is that remember, normally when you call a derived class, if you don't have a function overriding, you still have the base class function. So this will not break your code. It will just have memo say hi for the first 2, and finally cow says moo. It will run. Is that my desired behavior? No. Will that break my code? No. All right? So how do I get to my desired behavior? This is pure virtual function. Pure virtual function does not mean that you put in the pure keyword at the beginning. You put in equals 0 at the end. Why is that? So first of all, before we talk about why equals 0, pure virtual function has this property of enforcing any of the children, they have to overwrite this pure virtual function. They have to. 1. The second thing is, I do not need to write. That's why it's equals 0. Equals 0 basically replaced the curly bracket or anything that go after that. Right? Normally when you define a function, you do a curly bracket and your content, you close it, right? I'm going to replace the whole thing with equals 0, saying that I'm not going to define anything. I'm a base class. I'm going to have my children here. All right? So virtual function makes dynamic binding. Pure virtual function makes sure you have something to be binded with. that make sense? Now, because we have what we call a pure virtual function for the class memo, a class with at least one pure virtual becomes an abstract class. What is an abstract class? Abstract class is a base class that is too abstract. TLDR of this whole page. Okay? When do we think of class being too abstract? First of all, it is too abstract that you can't even use to create any object. So abstract class will not be used to define any object. Okay? The only purpose of an abstract class is so that it has derived classes. So the only purpose of an abstract class is being a base. It cannot create object because it's too abstract. What object I'm going to create from it is too abstract. It's not well defined enough. The classes that we have been seeing that can create objects are called concrete classes. An abstract class is a base class from which other classes can inherit, so we talked about that. And we define abstract class when it's too generic to define. So memo is a good example. Remember when I talked about defining the talk function for memo, I was like, I don't know what the memo is going to talk. Exactly because it's too abstract. You don't know what memo it is. I'm not going to know how it's going to talk. So ideally speaking, when I have this abstract concept serve as base, I don't want to define a lot of things in there. But I do want my children to. I do want all of my animals to talk. So the way you enforce it is that you have a pure virtual function in your class. So again, another example. I have a base class shape. Remember, we had an example of that. A shape class which can have derived class circle, square, rectangle, and all the other shapes. Say I have a function called draw. I want all my shapes to be able to draw the shape with some parameter, right? Maybe 1, 1, 1 for the square or things like that. For the shape class to define this draw functions makes no sense. I don't even know what shape I'm drawing. How am I going to be able to draw? So for the base class as shape, for the draw function, most likely pure virtual, right? Equals 0, not going to define it. However, all my children, you have to define them. You need to be able to draw your own shape. Does that make sense? Yeah.
That makes sense. It's just like, for example, for let's say for class circle, we just don't want to use that, but we must override it in the function. What we have to do?
Yes.
Like
If
if for example
pure.
for all of them we're gonna use, but like just for circle, like let's say we're not gonna use the shape, but based on the explanation we must like.
You must. Yes.
We just have to.
You just have to. Which brings up a good question of why do we have this, right? In your base class, you can choose to have regular function, virtual function, or pure virtual function. When do we use what? When you want to define a blueprint, meaning that here's my structure, you need to follow exactly those 3 functions. Require function, pure. You have 3 more functions that I'm going to give you a default definition. You can decide to override it, enhance it, or not. That's virtual. Exactly. And then if you have functions that all of your children is going to share, most likely they will not override it. Regular functions. Right? That is the design of your base class. You got to design as a software engineer how you want to structure your base class, what type of functions you want them to be. That basically define everything downstream. You give other programmers who use your base class a very good guideline. They're, oh, okay. You want me to have those 3 required, those 3 are optional, those 3 I do not need to define. It's already defined. I just call them.
Okay.
I have a question.
Yes.
regarding the previous. So it's written in the 4th line that class that's too generic to define. Well, too generic is a little bit too generic.
Indeed. That's why I'm saying TLDR, abstract class is a class that's too abstract. Right? I already put more words for you. but so that is again a design question. Every people will consider their class differently. I think my memo is too abstract because when I define, so most likely this is how I'm going to write my code, right? I'm going to write a memo. I'm going to write my function talk. The minute I got to there, I'd be like, what I'm gonna write for this function talk. I don't think I can define it, but I want my children to define it. I then put this function as pure virtual. That is why you don't define a class as abstract class. You see that we don't have any keyword of abstract anywhere because it's not a definition of a class. It's your design of that class makes it abstract. So that is why the abstract class has one or more pure virtual. It's not that, oh, I'm going to make this abstract. No, right? Whenever you have one or more pure virtual, that makes the class abstract.
So, for example, we, I think we had a case with a student class.
Yeah,
right?
student classes.
So, for example, we have a code where we have an IVC student and
Okay.
a Saddleback student
Okay.
class, which are derived from the
Okay.
student class.
Mm-hmm.
Like looking through the code, we cannot find an object that is defined by a student class, which is initiated.
Yeah.
using,
Instantiated. Yeah.
Instantiated.
Yep.
You got me. By that class, but can we then say that it is an abstract class or not? If it's not used in the code, only classes are derived from it. Is it enough to claim that it's abstract class?
That's not. That's not.
Okay.
So you can choose not to use any concrete classes in your main. That's fine, right? Does not mean that if you don't use it, it's abstract. No. The definition of abstract is based on the design of the class. What function do you have in there? So it's not the other way around. I know that as a side effect, kind of, that when you have an abstract class, you cannot create object. Because it's too abstract, it makes no sense for you to create an object with a function that's not even defined. So C++ is trying to prevent that from happening. Therefore, it says, okay, abstract class, you cannot instantiate object. That is one.
I'm just trying to understand if I see a program, how can I see an abstract class in it? Like,
You have to find a pure virtual function. That's the only way you know.
oh, okay.
That's the only way you know. If you can find at least one pure virtual, that's abstract. If you cannot find it, that is not abstract.
Okay.
That's the only indicator of abstractness.
Okay.
Yeah.
That's a good definition.
All right. Any other question on this? Yeah,
So abstract classes can't be an object.
that's right.
Wait, so pointers aren't objects?
Pointers can point to objects, yes. Yeah. Yep. All right, here's an example of the abstract. Your compiler will catch it for you. When you have an abstract class, right, like some of you said, oh, it's so hard to know it's an abstract. It's not going to be, if I search abstract, it's not going to come up, right? But when you're trying to define an object from a abstract class, define an object from an abstract class, you will trigger a compiler error. It will be like, nope, object of abstract class, not allowed. Right, so your compiler will catch it for you, which is quite nice. Another thing that your compiler will trigger is that the minute you have pure virtual function, you cannot have something like this anymore. The minute that you be like, oh, I'm going to create a class called dog, I'm going to inherit from memo, I'm not going to do anything. Nope. Arrow, class dog, object of abstract class type dog is not allowed. Pure virtual function memo talk has no overrider. Very clear, very specific. You know exactly, be like, oops, I need the talk function because this is pure virtual and I did not override it. Yeah? So your compiler is pretty good with helping you when you're writing things because there's so many relationships going on. You're like, wait, which one is abstract again? Which one is the class? Which one is the object? Where's my pointer? Right? when you're trying to go through that, your compiler will try its best to help you to understand the relationship between classes, your pointers, and so on. All right, finally, we're ready for our example. We have an base class memo that has a pure virtual function. Immediately turn this into an abstract class which required any of the other classes to override the specific function. So this is where we are calling the blueprint, right? Required for all my children to write them. And that's good. The minute you have that, when we have our main, I have my base class pointer, memo. Now can point to my different objects, cat, dog, and cow. Depends on what being pointed to what. It will then go into memo talk. It will trigger the corresponding function through dynamic binding, right? And when you have that pointer points to another object, it will trigger the corresponding function in that different object because it's dynamically bound. Perfect. That's all I'm going to cover today. Right? I'm not covering anything else. I'm going to do exception the next week. I want you to take this week to not only try to get this, but also make sure you're solid on inheritance. Because without inheritance, this will not make sense. You're like, what is she talking about? But the behavior that we just saw from the previous example is called polymorphism. The behavior of C++ where you can handle a family of classes all at once. And that is polymorphism. Within this class, we talked about function binding, right? By default, static for C++. But it also has dynamic binding where you need to use virtual function to trigger. Once you have the virtual function which trigger dynamic bounding, then you can go another step if you want that to be pure and enforce all of your children to override it, right? Once you have that, the minute you have that, you turn your base class into abstract, cannot create object anymore, does not need to define function anymore. Right? We good? All right. Next week, we will have final project out, right? We will have the final class exception. So I'll talk about exception, and then we'll go into final project, which you then have 3.5 weeks or something like that to finish. Final project will use everything in this class. Now you'll be like, okay, so tomorrow's the last class. We have 2 more weeks. What are we going to do? You have an optional class that's coming. In that class, the topic is called What I Wish I Knew Before I Get into Industry, right? Unfortunately, those things have not been officially taught even through my grad school. But I had to just learn off them and be like, oh yeah, I need to do this. Some of you probably already know we have version control, right? GitHub, if some of you probably are already using it, it's super common in industry, you have to know it. And then we also have unit testing. Another pretty good practice when you go to industry is that you always test your code. That's optional, not required. If you are trying your best to understand what we have covered so far and trying to spend more time on your project, you don't have to, right? Those classes are not recorded either. Let's think of it as a bonus. If you're not going to come here, you have a bonus 3 hours to finish your project, but I highly recommend it. After that, final review. So I'm going to do final review before final, so it's fresh. I'm not going to do it 2 weeks and be like, I forgot everything that she said already. So I'm going to do the week before final. We're going to do final review on everything. That will be super useful for reference for final exam. Hint. So that we can go over most of the definition for every concept we have covered at the last week. And the week after that, final exam. Come here, I'm gonna release it all at once when you are all here. Similar thing, open book, open note. not open line, online, not open GPT, okay? You have to be here to do it. I'm gonna open it and you can all get it at the same time. I'll be here to answer questions. Same question type, multiple choice, matching, true and false. Same thing as your midterm, just more. All right? Perfect.
One question.
Yes,
Final covers everything from the beginning? Or
from the
just
beginning.
From the beginning.
From the beginning. It will weight a little bit heavier for the second half, but it does have something that people tend to miss from the first half. Kind of every.
Did you say open note?
Yes, open note, open this, open